All right, in this lesson, we are going to begin by talking about integers and opposites. Now, in these videos, I'm going to start with what I like to call our essential questions. And these are questions that you should be able to answer at the end of the lesson. So I would use these questions as kind of a guide to note-taking and making sure that you get the most out of each lesson. So if there's any of these questions that you can't answer, make sure you ask questions about those at the end. So the essential questions for this video are, what are integers? So one of our objectives is knowing and identifying what an integer is, and can I label them on the number line? So can I find these types of numbers on the number line? And then once I do that, can I compare the integers? Can I tell which ones are greater or which ones are smaller? Or can I put them in order from least to greatest? Also, we want to talk about a concept called opposites. Can I identify the opposite of a number and label it on a number line? And can I use integers to describe real-world situations? So we're going to be talking about integers because we're going to be using those a lot in these first lessons. So what are integers? So integers are positive and negative whole numbers and zero. So here I have the definition of integers. This would be a really good thing to add to your notes. So just a reminder, at any time in these videos, it would be a good idea to pause it and take notes when you have definitions or answers to our essential questions. So here I have a Venn diagram kind of describing and laying out what integers are. So like I said, integers are positive and negative whole numbers and zero. So when you first learned how to count, you learned how to count using what we called the natural numbers, and that's just 1, 2, 3, 4, 5, 6, so on and so forth. So you learned to count up, and you learned how to count higher and higher and higher. Eventually, you learn a new number, which is zero, and then that is added to the mix. And we call zero and the natural numbers together, we call those whole numbers. And you use these numbers a lot at the beginning of elementary school. Well, now we're going to expand that number set to include whole numbers and negative whole numbers. So now we're going to include -1, -2, -3, -4, and so on. So we're going to go to the left of zero on the number line, or less than zero. All of these numbers together are integers, okay? So integers are positive and negative whole numbers and also zero. And here we have a representation of our integers on the number line. We have negative integers that are less than zero. They go to the left of zero on the number line, and zero is neither negative nor positive, but it is an integer. And then we have the positive integers that are to the right of zero on the number line, and they increase in value as they go to the right. And in these boxes, I've got examples of integers, and then I've got examples of non-integers. So integers all in this box, these are all whole numbers and negative whole numbers. So we've got 0, 6, negative 945, 147, 2, -64, 98, so on. All of these are integers. And then in the right box, I've got some examples of things that are not integers, like 25 hundredths. That's a decimal value. That's not a whole number value or a negative whole number. 1/3, a fraction value. Here we have a negative decimal value. Here's another decimal value. And here we have a mixed number. All of these are examples of non-integers. Those are not integers. So those aren't the numbers that we're talking about in this lesson. So here we want to see if we can graph numbers on our number line or identify where they're at on the number line. That was one of our essential questions. So I'm going to locate these and put a dot right where they are. So A, I'm going to find 5 on the number line, and that is located right here. So I'm going to put a dot, and I'm going to label that A. And then B is at -5, so that's to the left of 0 over here. There's B. C is at 0, so that is right here. Label that on the number line. There's C. D is at 4, which is right here. E is at -7, which is right here. F is at -3, which is right here. And G is at 9, which is right there. So pretty easy to find integers on the number line and label them and graph them and so on. So the next thing we want to talk about is comparing integers. Now, numbers that are further to the right on the number line are greater in value, and numbers that are further to the left on the number line are lesser in value. So as we go to the right on the number line, you can see here this blue line going to the right. As you go to the right, the value of the number gets greater. And then as you go to the left on the number line, the value gets less. So if it's further left on the number line, it has a smaller value. If it's further right on the number line, it has a greater value. And then just a reminder, in this box, remember these signs. If you can't remember these inequality signs, please take notes and write those down. This symbol right here, that arrow pointing to the left, means less than, and the arrow pointing to the right means greater than. So let's make some comparisons here of these two numbers. So I've got two integers graphed on each number line, and I want to compare each pair of integers in two different ways. So what are two ways that I could make a comparison of these integers? Well, on this first number line, I have -4 and -1 graphed on the number line. Now, -4 is further to the left on the number line, so I could say that -4 is less than -1. So I could write that like this: -4 is less than -1. However, I could also say that -1 is further to the right on the number line, so -1 is greater than -4, so I could also write that. So I could say -1 is greater than -4. Both of these are two different ways to say essentially the same thing. We're comparing the values of these integers. So let's try it again on the next one. Here I have 0 and -8 plotted on the number line. Now, one thing I could say is that -8 is further to the left, so -8 is less than 0. That would be a true statement. Or I could turn it around and say, well, 0 is further to the right, so 0 is greater than -8. Both of these are correct, and two ways to make that comparison. And the last one, I've got -2 and +2 on my number line. So again, -2 is further to the left, so I could say -2 is less than 2. Or since 2 is further to the right, I could say 2 is greater than -2. Two different ways to use those inequalities to make comparisons of our integer values. And that's comparing integers on our number line. Next, we want to talk about opposites. Now, opposites, here's another definition that we might want to add to our notes. Opposites are numbers that are the same distance from 0, but on opposite sides on the number line. So you can see I've kind of got it color-coded here in a nice, beautiful rainbow color of pairs of opposites. Now, 0 is its own opposite because 0 is at 0. So it's the same distance from itself, I guess you could say. So 0 is its own opposite. And then as we work out in our integers, we've got -1 and +1 right here. Here's 1 and here's -1. And you'll see that these are the same distance from 0. They're both 1 unit from 0, but on opposite sides. So we say 1 and -1 are opposites. Likewise, we have 2 and -2. These are opposites. They're the same distance from 0, but on opposite sides. 3 and -3 are opposites. 4 and -4 are opposites. 5 and -5 are opposites, 6 and -6 are opposites, so on and so forth. So we can continue on like that forever, identifying opposites. So pairs of opposites are the same distance from 0, but on opposite sides of the number line. So here on the number line, let's identify the number and its opposite on the number line. So here we have -9. So -9 is right here on the number line, and then 0 is right here. So its opposite would be the same distance from 0, but on the other side. So that would be +9 is its opposite, and that's right here. Notice that they are the same distance from 0, but on opposite sides. So 9 and -9 are opposites. 6 is located right here on the number line, and here's 0. So it is 6 units from 0, and its opposite would be -6, which is also 6 units from 0, but on the other side. So 6 and -6 are opposites. And then lastly, we have -3, which is right here on the number line. And here is 0, and that's 3 units from 0. So its opposite would also be 3 units from 0, but on the other side. So that is +3. So -3 and +3 are opposites. Now that's pretty basic too, and that's what opposites are. Lastly, we want to talk about integers in real-world situations. So for each one of these statements here, I want to write an integer for each situation, then identify its opposite, and then describe what it means. So 23 degrees below 0, or sorry, 23 degrees Fahrenheit below 0. Now, since we're below 0, that's going to be a negative value. It's under 0 or less than 0. So the integer to describe this would be -23. Now, its opposite would be +23, and that would represent 23 degrees Fahrenheit above 0. or warmer than 0. So that would be its opposite. The next one, we have a loss of 8 yards. So maybe we're talking about football here. So a loss of 8 yards means that we moved backwards 8 yards. So this would be a -8 for an integer that would represent that situation. And its opposite would be +8. So that would be a gain of 8 yards. That would be the opposite of a loss of 8 yards. And then we have a deposit of $15. Now a deposit, that means you put money in the bank. So that means you gained $15. So the integer to represent that would be a +15. Now the opposite of that would be -15. So that would be like taking $15 away from your bank account or spending $15. So we call that a withdrawal of $15. So that would be the opposite of a deposit of $15 would be a withdrawal of $15. So again, that's what our integers are. So to recap, integers, those are those positive and negative whole numbers and 0. And comparing integers, we can use the less than and greater than symbols to do that. And then opposites are numbers that are the same distance from 0 but on opposite sides. And then using integers to describe real world situations.